thing
That's some of my
Yeah,
stuff now.
back
That's
out
some of
there.
her stuff.
I didn't put it back on. I can do it tonight.
we're gonna put another mapping link back on the Slack, talk group. And it's got several videos, and you kinda just watch them one right after the other. You may fast forward through some of them because it's, you don't wanna hear part of it, but for the most part, it's pretty good. Starts basic and keeps going.
And I'll send it to whoever's on the Slack, an email.
Say what
I'll
now?
get it to. I'll send it to you guys via email, that way you guys can use it.
Oh, the flag?
Well, the video he's talking about, the video
Okay.
series, talking about the way you guys can have it.
Okay, great, thanks.
Like I said, this is a different, global mapping, but what, we use is the UPM to make one across the, longitude, latitude. But what we use mostly is the UPM. You have meridians and parallels that go around the earth. And you can see that areas get wider, and that's where it comes into that declination. But we don't change our compasses for that, we just keep it set with north wind up.
Because we're in the northern hemisphere.
Right. Longitude and latitude is, one method of identifying points, like I said, it's parallels of latitude, meridians of longitude.
I think that's right. I think we're in the northern hemisphere, right? No?
I mean, yes, we are, but
You operate off the
Or
south.
what?
it's, yeah.
Is it S?
Yeah, it is.
I've been very confused with that for a long time. And I always thought it meant northern hemisphere.
Right.
Mapping can get very
Okay.
confusing.
Oh, yeah.
Stand corrected. Sort of.
We're in the south now.
Yeah, true.
There you go.
Yeah, the South matters.
Yeah.
This is just more about longitude and latitude. The systems portrayed use part of the round of the earth and the flat of the earth. The grid system covers the entire globe. Longitude and meridians run north to south, and the latitude, the parallels run east to west. And it just takes a lot of practice. Longitude and latitude is not as effective for ground personnel, and it's better for aircraft and boats. That's why we use the UTMs, because it is more accurate. But it works well for all-around general use. Longitude, any point is measured by an angle in degrees up to 180 in any direction. Consider zero at the angular distance east to west, and 180 degrees towards the prime meridian. Latitude runs at angular distance, and it's measured in degrees of 90, being the maximum at each pole. It starts at the equator, which is considered zero. Then it's the parallels. I couldn't figure out on my computer how to make that little degree sign. So it, degrees, minutes, and seconds. The DD has the little degree sign. And then the degrees, minutes, and decimal minutes, those last two M's should be small, but for some reason it wouldn't let me do that either.
I want to just make mention of the degree of difficulty by using all these different ones, you know?
Right.
So if you go somewhere else and somebody else uses something other, then you're gonna have to deal with that or whatever, but
Confuses me.
everybody would just stick with one, the easiest one, but
which is the UTM.
this is a
And
UTM.
every search I've ever been on, they use the UTM, so, you know, makes life so much easier.
On your phones and your whatever devices you're using, you have to change that. That's an option for you.
You can put the degrees, minutes, and seconds in there and change it to UTM. Love Google. Distance hint for, most of your USGS maps. 1 minute of latitude, regardless of the scale of the map or the globe, equals 1 nautical mile, or 1.15 statute miles, or 1.18 kilometers. So therefore, 1 degree of latitude equals 60 nautical miles, or 69 statute miles. UTMs, it was designed as a special grid for the military use. The world's divided into 60 north-south zones, and each zones cover a strip of 6 degrees wide in longitude. So that's how it's divided up. And if you look at Alabama, we're in that 16. That's why when you look at your GPS, everything starts out with 16. You can get over in parts of Mississippi or down in Florida, you would revert to the 17. Coordinates are measured north and east in meters. 1 meter equals 39.37 inches, or slightly more than 1 yard. Northern values are measured constantly from 0 to the equator in a northerly direction. The equator was assigned as an arbitrary false northern value of 10 million meters. Central meridian through the middle of each 6 degree zone is assigned to an easting, which is 5,000 meters. This is a lot, we don't really, but this is how UTMs was designed. UTM grid lines are shown on all USGS quadrangle maps. They're indicated at intervals of 1,000 meters, indicated by either blue tick lines in the margins of the map with a full grid line. The 1,000-meter value of the tick lines is shown for every tick of the grid line. So that's what Bobby was showing y'all earlier, the little tick lines where you can measure out your feet. So, in between each large grid line is 1,000 meters. A lot of this will go back to the maps and you understand it better when you go back to the map and do it. This is still a lot more than in-depth than what we really need as far as just understanding the UTMs. Getting the UTM coordinates from a map is very important, that all the maps are north is up. So what you want to do is start at the bottom or the top, well, at the bottom, and you read to the right to get your first numbers. And then you read up. Read to the right, and then you read up. topo map portrays the shape and the elevation of the terrain. Shown graphic representations of selected man-made and natural features to scale. So that's why we like the topo maps. You can look at your topo map, and when you see a ravine or what you see is a mountain, you can turn and look at your terrain and figure out where you're at. The USGS publishes topo maps in a variety of scales. The most popular for Landstar is the 7.5 minute map. They're supposed to be updated every 5 to 10 years, but sometimes it takes a lot longer than that. They accurately depict the terrain and the relief as far as elevation and slopes and the terrain, like a crevasse that goes down or a high cliff, you can see those on the topo maps. Man-made features might be a little different because man is going in there and changing the earth every day. So the top of the map is always true north. Vertical lines of longitude point north and south. Horizontal lines of latitude point east and west. And the best way I learned which way was horizontal and vertical is the horizon is horizontal. That's not easy.
I think that's where it came from.
I kept getting confused. Do what?
I think that's where the word came from.
But it had to click up here, you know. Topo maps are identified in the upper right margin of the quadrangle, the name, the state, or states in which it's located, and the series and the type. Usually named after a prominent or immovable landmark. The series refers to the area mapped in terms of minutes or degrees. And the type is either topographical or planimetric.
What is planimetric?
I don't know.
Mm-hmm.
Do you?
No, not without Google.
Anybody?
Never heard of it.
I'm gonna guess it's your road maps,
Probably.
but that's just a guess. Google.
Google.
I shall Google.
I'm gonna guess it's in a plane, so it's your
Right.
2D,
That's a very good guess.
but that's just a guess. You got it?
It features extraction involved in the creation of maps that shows only the horizontal position of features on the Earth's surface. This reveals graphic objects, natural and cultural physical features, and entities without topographical properties.
Huh.
Such as roads, buildings, and water bodies that are visible and identifiable on aerial photographs.
So it's one
Good job,
dimensional.
Becky.
Right.
I can't take you anywhere.
Geographic coordinates are shown at all 4 map margin corners along the margin lines of 2.5 minute intervals for a 7.5 minute map. The legend is usually located in the lower left margin, which credits the legend cannot be readed, so as far as what they put down there, that may not all be what you see on the map. Or you may see more on the map than what's put down there. Like I said, we don't do the magnetic declination, we just keep our compass set on 0, and unless we're in an area where the magnetic declination is way off. But if you set your map and compass together, you're going to get into the area and very, very few meters from it.
We generally don't travel far enough for it to matter,
Right.
from one spot to the next.
In this area, it's either 6 or 8,
2
Yeah.
or 3.
2 or 3.
It's 3 degrees.
Three. And 3
It's changed that
degrees
much.
is not gonna matter unless you go out
Because
about,
it was, it's
20
7
or 30
in
miles.
Charleston.
And then you may be off some.
But you're gonna have a lot more other error that's you're gonna cause rather than that, worrying about that destination.
Right.
So do all search and rescue they don't use magnetic?
Yeah. They use the, true north and they just forget about the magnetic tip.
And I say all in our area.
Yeah. Everywhere I've ever been, they've never,
Worried about it.
yeah. And this shows you what they mean by the magnetic north and the declination. Magnetic north, you can see up there in the declination, this one's off about.
Well, this is kind of disappointing information, because I try all the time in my fields to start somewhere and go somewhere. And I always figured it was because my compass was off, because I never make it right to the point, and now I know it's just because I suck.
And a lot
I
of
was
times-
blaming it on this.
A lot of times, if you have a point to go to, so we put out a sign that has an M on it, you're not gonna be just right footstep on that M. You may be 4 feet over here, or, it's not an exact mapping. I don't know how to say
We just
that.
don't have a level on foot for accuracy.
Right.
It's just not, it's not happening.
Not shooting a laser
Yeah, but
beam.
that's what I
Yeah.
tried for.
Right.
I want to get right there.
Yeah.
Oh, well.
I'm just happy to find the truck on the way back.
If
Where's
you
the
strive
truck?
to be right there, then you're not gonna be that far off.
Yeah, well, I know you can shoot left, like on a trail, and then just follow it right. I'll shoot, but I've never been able to get from one point to the next, going through the woods.
Well, we're gonna work on that too when it's better weather. We're gonna set up a map course out in the woods and let y'all take your map and compass and travel through
Yeah.
the woods.
Yeah, I've never made it.
This is all about the publications and where you find your information on the map. Road symbols is the legend placed at the lower right margin. It's tailored for each map, so the legend will all be different. Trails are not included on the legend unless there are no roads on the map. Then you'll find trails. Just a few of the symbols for roads. When you look at a map, you'll see the primary highway will be a dark red line. Secondary highways will be red and white. Improved roads that are fair and dry weather will have just the dotted line. If that may be a trail or just a, say, logging road or something like that. And a light duty road, sometimes is the roads that we travel to get to some of these circles. Will just be the two dark lines. The contour lines will be in brown. Vegetation is in green. Water is blue. Man-made objects is usually black. And roads and built-up areas are red. And the new changes or updates on the map, that man has done and all this other stuff is usually in purple.
So now question whenever we did the map, we went and found the first spot on that one map. What color was it? So what does it mean? What it is?
Well, to me, it looks purple, so it must be a new change or an update.
Okay? So we don't really know what it is, it's just something.
Mhm.
It's not blue like it's a pond.
Mm-hmm.
And all this information is chapter 10 in your StarTech book. So, you know, you don't have to be hard on taking notes if it is in the book. Contour lines represent elevation. Each contour line connects all points of the same elevation above sea level. And there's three types. There's an index line, intermediate, and a supplementary. Every fifth line on your contour is darker. They have numbers superimposed on them indicating the elevation along that particular line. The lighter, you have lighter brown lines which falls between those index lines and they're not numbered. That just means from one dark line and then you count your lighter lines, you get up to your next elevation, which it may say 500 here on the dark line, and then have 5 or 10, but maybe 5 light brown lines, so you know the next dark line up here says 600. So each one of those light lines would be 200 feet in elevation. Dashed lines may be used when the terrain is very flat. There are large areas between contour lines, and it shows a difference in elevation that is half of the elevation of the contour lines by where it falls at. Terrain features involved with a complex landmass as a ridge line. A ridge line is a line of high ground, usually has variations in level along its top. So when you get to the top of the mountain, on this side the lines may be very close together, which means it's steeper. On this side they may be farther apart, which you know is going to be a sloping terrain. So if I was going to have to get to the top, I would probably want to go that sloping terrain instead of climbing that steep.
You'll find that part is important.
Right. So the closer the lines, the brown lines are together, means the steeper the terrain is. Terrain features, you won't see it like that on a map, but you will see the contour lines, and you can tell which side of the mountain is steeper than the other. On a topo map, you will see the creek or the valley running through 2 maps. And what's that called?
What? Saddle?
Saddle. And I meant to put all those, I think I did that. You have your major terrain features and then minor terrain, which the minor may not all be on there.
I don't understand the first line.
A total of 10 natural or man-made features may arise from a ridge line. So you're going up that ridge line, you may see a man-made road or something that gets you to that top, so you can tell that, hey, here's a man-made road, we can travel that, or either walk that, so that you will see natural features or man-made features on your map that gets you to the top.
I guess somewhere along the way they've named 10 things, and it's possible
That
now.
could possibilities,
Okay.
not that all 10 would be on your map.
The book gives the picture on, 235. It says hill, valley, ridge, saddle, depression, draw, spur, cliff, cut, or fill.
Yeah.
Is that 10?
That's 10.
There it is.
There you go.
What is that?
So can everybody identify the hill?
Identify the top of the hill.
Looks like it would
Has
be
a number
the,
1 in it.
looks like it'd be the
Top of the
top.
hill. See how it's rounded? Everything is traveling up to that round point, so that's the top of the hill.
It says number 1 is hill.
Yeah. The valleys are usually the lower points at the bottom of the hill.
Some of them are, in my mind, like 6 and 7, draw and spur and,
Yeah.
you know.
To me, that's it, I call it a crevasse or a draw, whichever one.
Big ditch.
So what is this?
Railroad track.
Secondary.
From the looks of it, it's a railroad track.
It's not railroad
Yeah.
tracks.
It's a road, that's a bridge there.
Big
Secondary
bridge.
road, it's a broken.
See, this is blue, so that's water, so that's probably a bridge.
Uh-huh.
Right.
But this is showing you that it's cut through, it's probably a man-made, road. It's a secondary road, it's not like a major highway or anything. So it may be dirt or gravel, might have a little tar and stuff on it, but it may just be dirt and gravel. What is this?
Oh,
A lower place.
Yeah, this is low ground, and it may be marshy, because it has the peat lines in it, so it may be a little marshy.
Like a depression.
Yeah.
But you know, it doesn't have the blue ponds, which are exactly the same thing, except they got water in
Maybe a
them.
sinkhole.
Right. These are ponds.
It's not necessarily holding water, but
Yeah, it's just marshy, wet. Yuck,
Yeah.
sort of like.
it's a mud hole.
Meridianville,
Meridianville said.
No, my house.
Marshy, wet,
Gravel pit?
so what's fill? What's 10? I don't understand. They never have.
it might have been filled in,
I'd say they filled up to make
man-made.
that road level.
yep.
Yeah, they probably had to fill that in to make that bridge across that creek there.
That's the part that made me think railroad track when I looked on solid. That's railroad ties.
Yeah.
But it
It is
doesn't
a
have the
travel way.
railroad ties all the way down the road, so it's not
Yeah,
a
I just,
railroad. It's just where they had to fill in, probably
It's
to
some
get
kind
the
of
road
bridge.
more stable to go through.
I don't know. Got an overpass.
So your major features are your hills, saddles, valleys, ridges, and depressions. And your minor features are draws and spurs and cliffs and cut-throughs and fillings.
I wouldn't get hung up on all the,
No, just some of the major features you may see when you test. Did y'all see that when y'all did the written? Did it ask what's a saddle?
I think it asked for saddle.
Yeah, so
I don't
those,
remember that.
the major features you may want to, learn how to identify them. Identify stuff like this on a map, because that may be on your SARTEC test. So when you look at the map, you want to know, I'm looking at this map and I'm giving this area to search, I need to know what this is.
Yeah, it did.
I need
It gave
to know.
coordinates and it said what is on the map at this coordinates and it had the choices of those.
So the coordinates may be to here and they're asking you what is that?
Yeah.
So you do need to be able to identify that on a map, because that will be on your SARTEC test. And that just helps you when you get a topo map in your hand, and yours, or it's on your GPS, like Ryan's put it on your GPS, and it says to go here and search this area. Well, you look at it and you go, okay, here's this, and you know where your area is at, and you can see what's in your area and the best way to get to it. You know, if you have ridges or just hills, you know, I'd rather climb a hill than I had a ridge. I'm old. Take the path of least resistance.
Do some side hilling.
Always orient your map and compass. You want to get your map, like I said, it's always pointing north. So you want to get your compass and lay it on one of your major grid lines. This little map doesn't have it, but you lay it on your grid line. So, and then you turn your compass to north so that you can turn, and you've got your map is pointing north, your compass is pointing north, so you want to get your little dial so that you're standing north is straight in front of you. So then you can look around and go, okay, here's that hill, here's this, you know, and here's this, and you orient yourself to the map and orient your map and compass together. Just some little effects.
It took an hour to do that.
Orient your map and compass together. What were they doing?
Which way do we go, George? Which way do we go?
We were actually being stretched proportionately.
Of course. Everybody's
Yeah,
center there.
really.
I did stretch the picture to get a full, video.
Well, it seems you stretched it this way and shrunk it.
I don't feel so short anymore, Bobby.
Made
Just trying to make you guys not.
it a little bit shorter, more on Bobby's
But look at
level.
Bobby over there, barely seeing over Amanda's shoulder.
I'm not in the picture. Leave me alone.
There you are, see, right there at Amanda's picture.
That
Right over
top
at
right,
Amanda's
that
shoulder.
little bit looks like.
And they're all the same height.
Missy and
I think I took
No,
the
I mean
picture.
right over the shoulder.
No,
Oh, yeah.
How can you take
The
a
middle.
picture when you're
Yeah.
outside?
I'm not in it.
Yes,
That's
you
you
are.
there. Right there. That's
Oh,
your
is that
bald
my
head.
eyes? Okay, that was my
That's
eyes.
true. That's you.
wearing shorts.
Dang, I'm still
So
shorter than them.
what were they doing, or what could they have been doing? They could be standing there with their map and compass and getting everything coordinated together before they went out into the field.
No, we were sitting there going, this SARTEC test is a lot more intense than what I'd anticipated.
It is. But look, y'all had buddies. When I went and took it, I didn't know a soul up there. But thank goodness, Memphis Police Department was there doing it, and I buddied up in that group, going, they got to know what they're doing.
Yeah.
Not necessarily.
Well,
And when I went out to do my map and compass, you know, you do that by yourself, your map course. And I stood there with my coordinates he gave me, and I had my map, and I had my compass, and I had my coordinates set, and I stood there like this. Well, the next person behind you, and behind you, and behind you can't go till you go. And I kept standing there, and I'm looking, and I'm like, you know, if I make the first steps and I'm off, then the whole thing's screwed up. And the guy behind me looked over and he said, it's correct, let's go.
Aha, so you cheated. Got help from outside.
I was just so afraid to take that first step and start going. And he's like, it's correct, let's go.
Start walking.
Because they couldn't go till I went. And it was funny, but, you know, luckily I did have it set. I went through the whole mountain compass course without any glitches and got there. And he said, what is this pace stuff? You're supposed to give me meters. And I'm like, huh? So I had to sit down and figure that out.
Well, when I started, mine was off, the first one, so all of mine were off, so I had to redo it. Luckily, I had enough time to go back and start over, so.
Well,
So it was time
there
too,
was one
huh?
girl with me and she walked it 3 times and come out of the woods halfway on her 3rd time and said, I just can't do it. You know, a lot of groups don't help prepare you for this, and help prepare you for SARTAC. I know what I went through, that's why I like to try to help prepare everybody for this test.
Then you've got groups like us who get in trouble for trying to help you prepare. We wanna help so badly.
I'm gonna take your phone. What?
Don't walk up there and
It
look
kinda
at the
reminded me of
source.
Joe
Trust your dog.
from the rescue squad.
Yeah, that's true with, most of us HRD people. It's the fact that I'm walking through the woods, dragging a body doesn't mean. Might be my husband, time he gets back from Las Vegas. Compass, mapping compass at night can be difficult because you can't see where you're going, you can't see those ridges and stuff like that, so it's harder to identify, to get land features to help you identify where you're at. So you have to, one thing they suggested is putting a dim flashlight underneath your compass so that it will shine through and you can see where you're going. And then you can point your flashlight in the direction of travel and see what's up there so you know how to get to that point. But, you know, don't shine the flashlight in somebody's eyes when you're doing it.
Oh, really?
How much more is there to this?
We can stop anytime and,
Okay, but you got 10 minutes more, or?
I don't know.
Hit
Okay.
escape and you'll see how many more slides you have remaining.
Oh, there's like 65
Okay,
She got about.
total. I tried to give y'all all I could.
we need it.
There's 2 types of compasses, orienteering and lenstatic. The orienteering is your best for SAR work.
Y'all have a compass you recommend,
Yeah, I was
a
gonna.
specific brand or anything?
I like the Brutons. You can go to, Academy's got some. Don't get those, I call them in a little tin can. I really don't like them, they're cumbersome. Did anybody bring theirs?
Sutos, they're real
Yeah.
precise
I
to
thought
me.
Those are good, they're not but $10, $20.
Careful with those,
As
though,
far
if
as
you put bug
style-
spray on your hands,
That's it, what is that, a
and you're
Ranger?
sweating,
No, this
you'll
is
run the
a
number, you'll ruin the numbers on them.
That
Yeah.
style is preferred.
If you have
in
bug
certain
spray on your hands,
So what-
and you
That
touch the
style
number
is
on your
preferred, but
phone.
this
You
style
might
is
try
good
it.
for
A
no
store
certain
that sells
brand.
Boy Scout equipment,
Yeah,
they use the same general type.
Walmart used to carry them, now they have those that are in the tin can thing, and they're not really good. They're harder to work with and harder to see in my,
Plus the clear ones, if you set it down on a map or something, you can still see through it
Right.
to get it lined up.
you can
better.
see that you're getting it on a grid line and what's around it and stuff like that. That's why I like those, and they're easy to work with. You know that the red arrow is pointing north, so it's very easy to work with. Different, characteristics on your compass, and you probably need to know some of this for the testing. It doesn't have to be hardcore, but they may ask what the bezel is or the dial, your orienteering lines, the magnetic needle. They'll probably ask what the direction of travel needle is, and so you'll need to know what those are on your compass.
They did the bearing and orienting lines, I know.
Is what,
I know they did the bearing and orienting lines, there were questions about that.
so write that down because y'all have the same test. It'll be the same test for the next 20 years. They had to go change it this year. Some of them have a sighting mirror, some of them don't, so you just hold it where you can see your direction of travel and decided out that way. We can stop right there and let her, whenever she's ready, Bobby. just-
She's ready, could maybe take a break, right, get up and walk around for just a second, and we're ready to go.
Is there pause on that?
Yeah, there it is, coming right.